So now again, just repeating the same thing that we discussed. This is nothing but the temperature time curve. And let's take this for water as an example, which is as per your ICSE 10th syllabus. And you are starting at this point, which is having ice at minus 50 degrees Celsius. So what will happen is this ice will slowly take up heat. Let's draw a steeper line here. I will draw like this. Okay. This will come to 0 degrees Celsius. And then this is like this ice, somebody is supplying this ice at minus 50 degrees Celsius with some heat. So the ice is slowly coming from minus 50 degrees Celsius to 0 degrees, but still it is at ice, it is ice. And then still the heating is happening. So now what will happen is 0 degree ice will start melt to 0 degree water. This is fusion process. This is fusion, the same thing just some time back we saw. So now minus 50 degree ice is getting converted into 0 degree ice. So after some time it is converted into 0 degree water. And now, very interestingly, this water will not have a steep curve. It will take a lot of time to convert into 100 degrees Celsius water. So steep as in I am saying about this theta. This theta 2. Let's take this as theta 1. This as theta 2. So now ice at minus 50 degrees Celsius slowly rises to 0 degree ice. You can signify this by using a temperature change. So you can see there is a temperature change, minus 50, minus 49, minus 48, 47. So it comes to 0. It comes to 0 after some time. Still if you are giving heat, that heat is just used by the 0 degree ice to break its intermolecular bond, and then it is getting converted into water. This is by virtue of its latent heat of fusion, and the process that is happening, like melting of ice from 0 degree Celsius to 0 degree water, is called fusion. This is not latent heat of fusion. Latent heat of fusion is the property of ice to convert from ice to water, but the process is called fusion. Again I am repeating, the process that is happening during ice getting converted into water is called fusion, and the property by which the fusion is happening is called latent heat of fusion of ice. Okay, so now after it is getting fused to water at 0 degrees Celsius, it is again gaining some heat. Still somebody is supplying heat, so it will slowly gain heat and it will increase in temperature, and this is by virtue of specific heat capacity of water. Again, this is not the process, this is specific heat capacity of water, this is property, this is process. And after some time it will reach 100 degrees Celsius. As it reach 100 degrees Celsius, again this is 100 degrees Celsius water, which is again like it's a flat line. This is 100 degrees Celsius steam. So again, now you should be able to say what process is happening between 100 degrees Celsius water getting converted into 100 degrees Celsius steam. This is called vaporization. And which property helps in this process is called latent heat of vaporization of water. It is interchangeably, you can say latent heat of vaporization of water or latent heat of vaporization of steam. You can interchangeably say, similar to that of latent heat of fusion of ice or latent heat of fusion of water. Interchangeably you can say, because it's just a phase change between these two. So after this point, actually it's not in your ICSE syllabus, but still I will just tell you, after reaching 100 degrees Celsius steam, again it will go increase in temperature, and this is by virtue of specific heat capacity of steam, and it will reach like some temperature, which the maximum temperature that it can reach is the temperature of whoever is giving the heat. Okay, so in a nutshell, I am just repeating the curve. So minus 50 degrees Celsius water is moving to 0 degrees Celsius ice. It's by virtue of specific heat capacity of ice. So specific heat capacity of ice is a property by which when you supply heat, so much amount of heat is getting converted into its average kinetic energy of the molecules, and average kinetic energy of the molecules is determined by the temperature. So the average kinetic energy of the molecules will increase and the temperature will also increase. After some time, instead of increasing the average kinetic energy of the molecules, rather it just breaks the intermolecular bonds between the substance present in water, which is nothing but the H2O molecules. So these intermolecular bonds get broken when it converts from 0 degree Celsius ice to 0 degree Celsius water, and the process is called fusion. And the property which helps this fusion to happen is latent heat of fusion of ice, and you can interchangeably say that as latent heat of fusion of water. So again, once the intermolecular bonds are broken and the water is converted into, ice is converted into 0 degree Celsius water. Now, again, the water at 0 degree Celsius will slowly takes up heat to reach 100 degree Celsius water. So this 100 degree Celsius water, how it is reaching is, you can clearly say there is an increase in temperature. Whenever there is an increase in temperature, that is because of the property specific heat capacity of water. Here you cannot interchangeably say that it's specific heat capacity of water and steam. This cannot be possible. Specific heat capacity is specific to a particular substance and particular state. But the latent heat can be specified with analogy to any of the states of that particular. For example, latent heat of fusion of ice and water, you can interchangeably say. Latent heat of vaporization of water and steam, you can interchangeably say. But specific heat capacity of water, ice and steam all are different. So you cannot interchangeably say that thing. And specific heat capacity, the property can be signified when you see a increase in temperature or decrease in temperature whenever you are supplying or removing heat. So after reaching 100 degrees Celsius, the water is again taking in heat, but here again, the intermolecular bonds of the water is getting broken and it is getting converted into steam. There is a change in phase from water to vapor, which is nothing but steam. And this process is called vaporization, and it is happening because of latent heat of vaporization. And here you can clearly say, as it's a property of latent heat of vaporization, you cannot clearly see any temperature rise because there is no increase in average kinetic energy of the body. So there is no increase in average kinetic energy of the body, which means there is no change in temperature. Rather, the energy that you are giving as a thermal energy is getting utilized to break the intermolecular bonds. So here 100 degrees Celsius, water is coming into 100 degrees Celsius steam. So after that, this 100 degrees Celsius steam is again taking in heat by virtue of specific capacity, because specific capacity of the steam, and it's slowly increasing in temperature, and the maximum it can reach is the maximum temperature of the of the substance which is giving you the heat. That is the maximum possible limit.